Hi everyone, now I will discuss with you about measure of central tendency, measure of dispersion, and measure of shape based on tabular data for sales data and profit data. Firstly, measure of central tendency is mean, median, and mode. The mean based on sales data is 0.44. For median is 85.05. And lastly, mode is 12.96. For measure of dispersion is variance and standard deviation. For variance is 237719.9809 and standard deviation is 486.5653605. For measure of shape is coefficient of squareness and coefficient of kurtosis. The CS is 8.1380800021. It is positive for right square data and high degree of squareness. For CK is 176 and 7311999. It is big illustration. Next, for mean based on profit data is 6599.98. For median is 9.24 and for mode is 0. For variance is 30394.77448 and for standard deviation is 174.3409719. Lastly, for CS is 4.157188533. It is positive for high degree and high degree of squareness. For CK is 291.4110896. It is peak with less dispersion.
Next, I will present about two sample tests for difference in means. Based on tabular database, we want to test the difference between two groups of customers at Asia Pacific and Europe for sale of furniture, technologies, and office supplies. The data collected from customers in Asia Pacific and Europe. Now, let's take a look for sale of furniture. The purchase of furniture with sale data file hypothetical shows the sale of furniture purchased by the customer between Asia Pacific and Europe. Therefore, we would like to test whether the average sale of furniture at Asia Pacific is greater than Europe. So, the result is the T statistic value is negative 0.053, which is a negative value, and it was lower tail. If the T statistic is negative, the p-value in the output is the p-value for a lower tail test. The p-value one tail is 0.478. As the p-value is greater than significant level, which is 0.05, we fail to reject the null hypothesis and conclude that the sale of furniture at Asia Pacific is greater than sale of furniture at Europe. Next, two sample tests for difference in means. We test for sale of technology. Okay, the purchase of technology with sale file hypothetical shows the sale of technology purchased by the customer between Asia Pacific and Europe. So, therefore, we would like to test whether the average sale of technology at Asia Pacific is greater than Europe. The T statistic value is negative 2.604, which is a negative value, and it was lower tail. If the test statistic is negative, the p-value in the output is the p-value for a lower tail test. The p-value for one tail is 0.00046. So, as the p-value is less than significant level, which is 0.05, so it can conclude that we reject the null hypothesis and conclude that the sale of technology at Asia Pacific is lower than Europe. Lastly, about two sample tests for different means for sale of office supplies. The purchase of office supplies with sale data file hypothetical shows the sale of purchase office supplies by the customer between Asia Pacific and Europe. So therefore, we would like to test whether the average sale of office supply at Asia Pacific is equal with Europe. As the conclusion, the T statistic value is negative 5.280 and the critical T value to tail is 1.96. The P value is 1.30301 exponential negative 0.7. By substitute the exponential notation negative 0.7, the P value is 0.00000013. The P value is less than significant level, which is 0.05. So from the result, the T statistic fall in the rejection region. Thus, we will reject the null hypothesis.
Assalamualaikum warahmatullahi wabarakatuh. My name is Syahirah Binti Hussain. Today I would like to talk about the analysis of variance, ANOVA. What is ANOVA? ANOVA is extremely useful technique concerned research in the field of economics, biology, education, psychology, business, industry, and in research of several other disciplines. Used to compare the means of two or more population groups. This technique is used when multiple sample cases are involved. ANOVA derives its names from the fact that we are analyzing variance in the data. ANOVA measures variance between groups relative to variance within groups. Each of the populations group is assumed to come from normally distributed populations. Type of ANOVA. They have two types. First one is one-way ANOVA. One-way ANOVA involves one factor accounted for. The researcher take only one factor involved hypothesis test where only one category, variable, or single factors is considered. It's a comparison of means of three or more samples. It were simply two samples that would use a t-test. It finds a difference among different categories when we have several possible values. Okay, for two-way ANOVA, account for two factors being investigated currently. The researchers investigate two factors at the same time. A hypothesis test where in the classifications of data is based on two factors. Two-way ANOVA examines the effect of two factors on the continuous dependence variable. So here I want to show the ANOVA technique by using the view. First step is I already choose the data from the Microsoft Excel and it will appear this data here. Okay, on the first sheet, they have columns and rows, tables, education, gender, status, years. Okay, for the columns, we pick gender. For the rows, we pick education, status, and years. Next step, we choose the chart. So I choose the chart. So the result is for gender female, the highest is married college graduate. For the male is married graduate degree.
Okay, hi, my name is Adriana. So I'm going to continue the previous. Okay. Next is we need to find the sum. Yes, and we click yes and employ in column. Okay, and then for row, we choose premium deductible. Okay, as we can see, we are adding the sum of years employed and premium deductible. Okay, so I'm going to pick the the suitable chart. Okay, so as we can see, this is the years employed with the status, premium education. So this is the table for divorce and married. Okay, so as we can see, for graduate degree, it's 60 is the most highest lah. Okay, so for the lowest, it's 2 years employed. This is for some college. Okay, so that's all, and thank you.
The chi-square test is a statistical method that research used to analyze the variation in the same population between categorical variables. The independent chi-square test decides whether there is a correlation between categorical variables, whether the variables are independent or related. It is a measure that is non-parametric. This test is also known as the association chi-square test. The test of independent, one of the most common use of chi-square test is the null hypothesis that when applied to a population of subjects, two classification criteria are independent. If they are not autonomous, then there is a connection between them. We prefer sales and benefit in this case. The most popular discrete data hypothesis testing technique is chi-square test. Two forms of chi-square test exist. For distinct purposes, both use chi-square statistic and distribution. A chi-square goodness of fit test decides whether a population fits sample data. A very small statistic of this chi-square test indicates that your observed data match extremely well with your expected knowledge.
My name is Nursulhani. The above pivot table summarizes the sales and profit value space divided into 4 other priority categories, which is critical, high, low, and medium. For the chi-square independent, the formula to the expected frequency is frequency for your column times the frequency for your row divided by the entire sample size of study. This is the example for the formula. Based on the calculation, we have the p-value of 0, which is extremely rare. A lower p-value is often interpreted as indicating that there is a stronger relationship between two variables. However, statistical significance means that the null hypothesis is unlikely to be valid, less than 5%. In theory, it is possible to achieve p-value of exactly 0 in any statistical test if observation is actually impossible under the null hypothesis.